to show that this series, 1 over the quantity n cubed plus 5, converges with the direct comparison. So we've got to compare the terms of 1 over n cubed plus 5 with another series. One that we know, because we're looking for convergence, what series that converges that we're aware of. So let's take the simpler version of what we have, 1 over n cubed. Right, again, this is a p series. It's 1 over n to the pth power, where p is equal to 3. Since 3 is bigger than 1, we know that this series will converge. Right? Now, what is this equal to? Well, if n is 1, then we have 1 over 1 cubed. If n is 2, then we have 1 over 2 cubed. If n is 3, we have 1 over 3 cubed. So on and so forth. Put in the pluses, why not? Okay, so 1 over 4 cubed. Plus dot dot. Right. So if we look at our terms, we have 1 over 1 cubed is just 1. 2 cubed is 8, so we have 1 over 8. 3 cubed is 27. 4 cubed is 64. So there's the first 4 terms. Take a look at the series that we don't know. Right? This one, we don't know whether it converges or diverges. But let's look at the terms. Well, when we plug in 1, we have 1 over 1 cubed plus 5. When we plug in 2, we have 1 over 2 cubed plus 5. When we plug in 3, we have 1 over 3 cubed plus 5. And when we plug in 4, we have 1 over 4 cubed plus 5. And this just keeps on going. So what do we end up with? Well, we have 1 over 6, and then 1 over 13, and then 1 over 32, and 1 over 69. Right? Let's compare these terms. 1 to 1/6, 1/8 to 1/13, 1/27 to 1 over 32, 1 over 64 to 1 over 69. 1 is bigger than 1/6. Or, if you prefer, 1/6 is less than 1. So I'll keep going this way. 1/13 is less than 1/8, because the denominator is larger. 1 over 32 is less than 1 over 27, and 1 over 69 is less than 1 over 64. So, this is the series right here that we know. This series converges. So the series that we know converges, and its values are larger than our unknown one. Right? So by the direct comparison test, right, we're showing that that 1 over n cubed plus 5 converges. Why? Because 1 over n cubed plus 5 is going to have terms which are less than 1 over n cubed. Right? And 1 over n cubed converges. That's the general idea behind this. Let's go in the opposite direction. With 28. We see 2 over n plus 1. So it's kind of like 1 over n plus 1 or 1 over n. So let's take 1 over n. Remember, we know that that one will diverge. Right, so we have 1 over 1, 1 over 2, 1 over 3, 1 over 4. I keep putting the plus, I'm sorry. Alright. Okay, so there's our terms. 1, 1/2, 1/3, 1/4. Now let's look at 2 over n plus 1. If n is 1, we have 2 over 2. If n is 2, we have 2 over 3. If n is 3, we have 2 over 4. If n is 4, we have 2 over 5. So what are the terms? 1, 2/3, 1/2, 2/5. Now we start to compare them. Remember, keep in mind that these terms right here come from a series which we know diverges. Well, 1 is equal to 1. But then we have 1/2 and 2/3, right? So 1/2 is less than 2/3, or if you prefer, you can go 2/3 is greater than a half. Same thing right here. 1/3 is less than 1/2. 1/4 is less than 2/5. Right? We can do the math here, right? This is 0.3, this is 0.5, this is 0.25, this is 0.4. Okay? So here's what we know. We know that this series right here diverges. And our new series has terms which are larger. So 2/n+1, that also diverges. Alright? Because 2/n+1, eventually, it didn't happen right away, but eventually 2/n+1 was greater than 1/n. And 1/n diverges. Right? That's the idea behind the direct comparison test. You're taking it, you're looking at a series which already converges and showing that your new series has smaller terms, so they must converge. Or you're looking at a series which you already know diverges, and comparing it to the new series, you see that the terms are bigger, so the new series must diverge as well. That's the idea behind the direct comparison.